251 Flatten 2D vector from LeetCode. Design an iterator to flatten a 2D vector. It should support the next and has operation. So based on this question, we know this is a design question and we are designing an iterator which is going to be a 2D vector, and it has two functions, next and has next. Let's see what each function does. The next function returns the next element from the 2D vector and moves the pointer one step forward. You may assume that all the calls to next are valid, and the has function returns true if there are still some elements in the vector and false otherwise. So based on this explanation, we know the next one will return an element from the vector, and the has next one, it returns true or false. So let's go through this example and see what this function, the iterator, is supposed to do. So let's say this is the input that is given to us, and it's a list of lists. And what we are going to do, first thing first, we are going to define the class with this vector. And then there is a next call here that we see, and we are going to return the first element of the 2D vector. And then we have another next, we are going to return the second element, and we have another next, we are going to return the third element, and we have a has next. And what this does, it's going to return true or false. It depends if we are done with the 2D vector elements or not. As you see, we have called 3 elements, and the fourth one has been left, and this is going to return true. And we call the has next again, and it's going to return true. So that shows it doesn't matter how many times we returned has next, as long as we have elements left in the 2D vector, we are going to get true out of it. And we call next function, and it returns the last element. And when we call the has next function again, it's going to return false because we have called all the elements from the 2D vector. So this is an iterator, and let's see how we can design this iterator. One way to design this iterator is to just because we know the nature of the input is a list of lists, we can use 2 for loops. We iterate over this list of lists, and we flatten the list, and then we can easily return the element at each point, and we can check if the length of the new array is not empty, we're gonna return true. But there are some problems here. The first thing is, if we do that, and if we do it in the constructor, which when we initiate the at this step, when we define the class, it's going to be very time consuming, and we should be very mindful about the time complexity at the constructor, and we should keep it at the minimum. We also should know that when we do that, it's gonna take so much space. It depends on how much input data that we have, and we should store it somewhere, and it's going to be very time consuming. Also, we don't know how big the input data is, and we don't know if the memory can handle that amount of data. Also, we should keep in mind that we are not supposed to touch the data structure of the input and not creating a new data structure. And the other thing is, we are building an iterator, and we might need to just return the first 2 elements of the 2D vector, and that should be enough. And why do we need to go through all of it? So considering all these things that I've mentioned, what we can do is we can use 2 pointers to solve this, to deal with this situation. We can use one pointer as pointer I to point at every single list that we have in the vector, and we can use pointer J to point at every single element that we have in the inside the list. So we are using these 2 pointers, and we define them here as I and J. So I is to pointing at each element of the main list, and J is pointing at each element of the inner list. So what we are going to do at each step that we call these 2 functions, which is next or has next, what we are going to do, we are going to check this, and we are going to say while I, which is the this pointer is smaller than the length of the vector, so it means we have still list inside left, and while and j, which is this one, if j is equal to the length of this, we are going to update I and j. So what do I mean by that? If we have any elements left, what we are going to do, we are going to increase the this pointer to 1, and we are going to which means we are going to the next element here, so we should reset j as well. So we are going to reset the j to 0. That's what this function do. So we are going to use pointers instead of like going through the whole vector and creating a flattened vector. We use 2 pointers to avoid that, and whenever it's needed, we are going to update these 2 pointers. So let's go through an example and see how it does. So we start with this going to start from 0 and 0, right? As we have let me move this here so I can write some stuff so make it easier for you to understand. So this is the top one is going to be 0 and 1 and 2, and the inner list that we have, this is going to be 0 1, this is going to be 0, and this is going to be 0. So let's go through an example. So let's say we initiate this. So we have initiated the class, so it's I is going to be 0 and j is going to be 0. Now we are going to call next, and when we call next, the first thing that it does is going to see if there is a next item, if any like item has left or exists. So it goes through this function, and this function, what it does, it says it's going through this function here, right? So it goes through this function. It says if I is smaller than the length, so I is 0 right now, and is smaller than 3, and if j, which is 0 now, is equal to the length of this, which is 2, and it's not, so we don't need to take any action here. So we don't need to take any action here, but this is for updating these 2 pointers, right? And what we are going to do, we are going to say if I, which is 0 here, is smaller than the length, which is 2, then we are going to return true, right? This is a condition, and if it is valid, it's going to return true. So if it is true here, which is true here, what we are going to do, we are going to get I0 and J0, because I and J are 0. And we are going to update j after, because after returning this one, we need to update j. So now we are going to return 1, and we are going to update j. So j is not 0 anymore, it's 1, and we have returned the result, which is 1. And then what we are going to do, we are going to call has next to see if any next exists. So what it does, it's going through this function. When it goes through this function, what it's going to do, it is going to see if I, which is 0 right now, is smaller than the length, and it is smaller than the length, which is 2. So 0 is smaller than 2, and j, which is right now j is 1, is equal to the length, which is 2, and it's not. So we don't need to do anything here again. So now it's going to return if I, which is 0, is smaller than 2, and it's going to return true. So let's call the next function again. So let's call the next function. Let me clean here. So let's call the next function. We call the next function, and let me clean this. So we call the next function, and it checks if it is true or not. So it's going to be true, we know that. And then it is called I is 0 now, and j is 1, which is going to be number 2 here. So it's going to add j to 2. It's going to be 2 now, and it's going to return the result, which is going to be 2 here. And now let's call the next function again. Let's call the next function again. When we call the next function, it's going to check if there is a next element. So what it does, it goes through the update pointer. So we need to update these pointers, right? So it says if I is smaller than the length, I is smaller than the length, so I is smaller than 3, yes. And if j, which is 2 now, is equal to the length, which is 2, and it is, now we need to update the pointers again. So what we are going to do, we are going to move the I to here, and we are going to reset the J to 0. And now when after doing that, we are going to see if I, which is 1 now, is smaller than 3, and it's smaller than 3, so it's going to return true. So we get the result here. So the result is going to be, so let's update this one. This is going to be 1, this is going to be 0. So the result is going to be 1, and it's going to be the vector 1 and 0, which is going to be 3, and it's going to add j to 1, and it's going to return 3. And this keeps doing that until we are at the end of the vector. And the space complexity for this case is going to be constant, and we have different time complexity for each function. Thank you.